rect variable. Okay, how to rect the data. So rect the variable. I forgot. Why rect? Oh, I think there is a better way than this. Okay, anyway, let's do the step by step. So, first, IBM, let's define IBM is, okay, FF, second one, right? Second one, so dimension of FF is, we have 166 data. So the first one is T, basically size of T. Let's define T, which is length of the data. Let's say call it dimension of FF, and the first element of the dimension of the FF. So this is basically T is 133. So it is the length of time series of the data. Okay, and the IBM is basically, it should be okay, it should be 1 to T minus 1 divided by, okay, FF, the second one. I think there is a smarter way than this, but it should be from second one to the T. Okay, so it is the ratio of the, so it means it is a ratio of the closing prices. And if I subtract 1, then it's a fraction of the data. And if I multiply 100, which means that I have a return data, right? So let's run the program. Oh, there is NAN, 2T, T, okay, let's check IBM. So I have return data now. Okay, now almost set. And then it's annoying. Okay. Okay. Then I want to consider excess return, right? So excess return of IBM is basically IBM minus, what's FF? FF 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6 elements. Okay? Right? So it should be excess return of the IBM, right? Yeah, something like this. So it is excess return over risk-free rate, right? And then I want to do Farmer-French regression. Farmer-French regression, which is regression of EIBM over minus 1 plus FF from 2 to, actually not 2, three, 4, 5. Okay. Let me try. FF 3 into 5. Looks like this. So I want to run regression like this. Okay, and I want to see summary of Farmer-French regression, right? So this is the end of homework. Your homework is that easy, right? Invalid. Let me try this one. It should work. Invalid. Oh, length. I should match the length. So, actually, it is the length of this IBM data is actually t minus 1. Therefore, actually, even this FF is the risk-free rate. It should be 2 to t. When I want to match the length. And then this is 1 to t minus 1. This is annoying. And market factor, define market factor as FF the third one. Size factor is fifth one. HML SMB actually. Minus here 1 plus market factor Okay, so Farmer-French 3 regression, 3-factor regression. So, well, I find none of the coefficient is significant, right? So, estimate t value is actually this is significant, right? No, sorry. We can check t value or p value, and none of coefficient is significant, right? So basically, Farmer-French 3-factor, at least at monthly frequency, cannot explain well. I didn't return well in this case. So in this case, at least, okay, intercept should be significant. So if we do this, yes, even intercept is not significant. Okay. No, anyway, this is the final output.
Professor, what if our analysis is not what if our p-value is over like 0.
So actually p-value in this table, to make this coefficient significant, p-value should be less than at least 0.5, less than 5.
You mean 0.05?
Yes.
But what if it's not significant? It says the output says it's not significant.
Yeah, it is insignificant. So it means that we can regard the coefficient. Okay, we can regard these coefficients are not statistically different from 0. None of the coefficients are significantly different from 0.
So basically, we cannot use this output.
So it means that basically we cannot reject hypothesis that Farmer-French defect model is wrong. For at least IBM, monthly frequency. This is usually it is so. I mean, for individual asset prices, they are so volatile. So even if Farmer-French defect model is right, it's not usually very difficult to reliably estimate those coefficients. So this is Farmer-French 3-factor model, and for capital asset pricing model, of course, CAPM is even easier. CAPM is simply this one, right? So CAPM is simply 1-factor model. So CAPM is simply, we can delete these two. So this is estimation of CAPM. And I strongly believe that this is insignificant as well. Right? This is not significant. And coefficient is 0.04604. Okay. And this coefficient is, of course, it should be same to the covariance of EIBM and MKF, market factor, divided by variance of MKF. Okay? This is the definition of covariance, definition of regression coefficient. So this number are same. Right? In capital asset pricing model, this beta, with this regression coefficient like this, and mathematically given presentation of this one is basically covariance of this excess return of this part and this market divided by variance of the market premium. So this is capital asset pricing model. Beta, excess this, and this is 1 factor. So in this case, since for capital asset pricing model, it means that beta is, in this case, beta is like a 4%, but still t value is too small, p value is too large, which means that this coefficient is not significant. Which means that this coefficient about 5%, right? It is not statistically different from 0. Which means that beta of IBM is not statistically different from 0, right? And it is unintuitive, right? IBM's beta is 0 means that, okay, IBM's beta is 0, which means that IBM has basically, since this part can be diversified away, expected return of the IBM is basically same to this coefficient, which is unintuitive. Right? Clearly, if IBM and US bonds generate exactly same expected return, what do you think will people buy? suppose if you invest in IBM, you expect you will make 10% until next year. And then you find out that if you invest in US dollar bond, still you can expect 10% return from it. Which one do you want to buy? I mean, usually people will buy US dollar bond, right? Because intuitively that's going to be the safer than IBM, right? It gives you exactly 10% safe return, and another one is volatile return. The expectation of it is 10%. Right? So in the case, everyone will want hold. I think US government bonds. So that's unintuitive, right? At least, I mean, intuitively, investing in IBM should generate higher return than investing in risk-free rate, which means that beta should be greater than zero. That's our intuition, and this statistically just reject that. So there's something wrong with either our analysis or capital asset pricing model.
I have a question. Then when the t-value is significant?
When t-value is significant, so it depends on degree of freedom. We actually learned this last week. So of course we have a very large data. T-value is like a z-value. Okay, z-value in this case. In that case, if z-value is like 1.96, something like that, it is 0.95%, and if it is like 2.33 something, and it is 99%. For t-distribution, it has thicker tail than usually the normal distribution. Right? But anyway, the critical value of the t depending on the degree of the freedom. In this case, the degree of the freedom is the data size minus number of parameters. So degree of freedom is 131. It is natural because we have 132 data and we have only one parameter to estimate. So degree of freedom is 131. Okay. And if we include so in this case we didn't include the intercept. Now suppose we include the intercept, then then degree of freedom is now 130, not 131, because now we have another parameter to estimate, which is the intercept term. Okay. This regression coefficient and standard error is I explained it is a regression error for the beta, right? So you can divide this one similar to standard deviation. Standard deviation of estimated beta. Okay, so it is basically ratio between the beta constant and standard deviation. So it looks like a z-value in the standard one, right? But since it is not exactly standard deviation, it is estimated standard error, not standard deviation. It is estimated. So it's a ratio between estimate and estimate. So it is a t-value, not z-value. If we know the true value of the standard error, standard deviation, not standard error, it should be z-value, not t-value. But since we use standard error instead of standard deviation, right, now we have the t-value. Right? And to know the p-value, we have to check the table of the t-distribution. In this case, since we have enough number of data, this t-value will be very similar to z-value. Let me check it. So, normal distribution. oops. D norm is okay. Standard deviation D norm. Density. Okay. To mean y. Oops. Is the same? Normal distribution R tutorial. Okay. P no P. Okay. Okay. D norm, C norm, P norm, and then this one. Okay. Okay, so P norm of T value is 0.323, which is like no. Okay, which is like 62%. So 63%, which is so 37%. So the difference between this and this is it is an absolute value. So actually, yes. So still this T distribution and normal distribution is exactly not same. We need more degree of the freedom. But anyway, yeah, I think in this case we need more degree of freedom. So still, even though we have 140 degree of freedom, it is not this some difference between T distribution and normal distribution. Any other question? So P norm is like this one. Okay? P norm is given the standard normal distribution. P norm is, I think, the value of size of this area. So actually, you need this P norm function if you wanna implement Black-Scholes formula, for example, right? In the Black-Scholes formula, you need a function for cumulative normal distribution, right? Cumulative standard normal distribution. So in that case, P norm will be value. Just to give you a Black-Scholes formula. Yeah. So okay. To refresh your memory, let's try the Black-Scholes formula. So Black-Scholes corruption formula looks like. So, okay. Write down bond price, which is a discount factor. F n d1 minus x and d2. And so B is the bond price, so it looks like something like this. F is the forward price, so F looks like S E R minus Q T. Q is the dividend rate. And T1 is log T, big T, okay? And T2, T1. Okay, this is Black-Scholes formula. So to implement the Black-Scholes formula, okay? So Black-Scholes formula would be something like this. Okay. So we can write down Black-Scholes formula. PS equal like a function of something, okay, even there, okay. We need first B, which is exponential of minus RT, right? And then F is S, spot price, and EXP R minus Q multiplied by T. Okay, something like this. And then we have what else we need? We need T1. S square and T, okay, divided by S T2는 T1 minus this part and in the argument we need spot price, we need risk-free rate, we need dividend rate, and we need maturity, and we need exercise price, right? So it is Black-Scholes formula. Oh, sorry. So therefore in the end we need PS is like P multiplied by F multiplied by P norm T1 minus X P norm T2, right? Dot R. So for example, PS Black-Scholes formula, and spot price is like 100, and risk-free rate is 0.05, dividend yield 1, and then yield time to maturity 10-year, exercise price 100, which is at the money option now. So, oops. So actually we need log, not ln. S가 없습니다. Yes, okay. Oh, I have to plug the volatility. Volatility is, let's say, 0.3. Unused argument. What is this? What is unused argument? T. I need a T. TT RQ. T1, T2, X, T10x unusual 100.
So what is capital S means?
It is spot price. Oh, okay. I have to distinguish this and this. Okay. The option price is like 45. Okay. So P norm is this area. So this function is very useful for the derivative class. Quantitative finance class. Okay, any question? Okay, now I'll give you the homework, another R homework. So since I gave you the formula for Black-Scholes formula, my next homework will be to calculate implied volatility. Okay, implied. So in this formula, if we have this input, we can calculate core value of the core option, right? Now, homework for tomorrow, for next week is given option formula. Okay? Given option formula, everything. I want you to calculate this volatility. So suppose we know all the other information, and then question is, for given or given other value, there is one-to-one relationship between core option and this volatility, right? This S value, right? This one-to-one relation. So in this case, we have this information and we want to know. But in your homework, suppose we know this part and we want to calculate this for S. This is called implied volatility. Implied volatility is basically root. Basically, it is the extracted value from the market price of call option or put option. In order to do this, I think you will need a solver called uniroot. Uniroot, I think, help. Uniroot. Okay, uniroot. Okay. It is the function uniroot searches the interval from row to upper for a root of the function. So for given function, it generally finds a solution, right? He finds a solution for the equation. So for example, okay, uniroot. Okay. So suppose let's define f as the sine, okay, so uniroot, so sine function, okay, uniroot is f interval lower interval okay, so uniroot sine function and then c minus pi, okay, sine function c pi over 2 and pi over 2, which is right uniroot, so estimated precision something like that, so the value is 0, right? Just one iteration it found the value. Okay, that's good. So let's define this one as the solution. And solution for the root is 0, right? So for sine function, right, I want to find the value, then the sine function is 0 between the interval minus half pi and plus half pi, right? So the answer should be 0, right? Alternatively, if I want to find the value which make cosine 1, right? So suppose I want, so this is the value of the x sine function 0. Now suppose I want to find value of x which make cosine function equal to 1, right? In this case, what I can do is I can simply subtract minus 1, and I want to make the point between minus half pi and plus half pi, and then makes this part 0, right? And then what should be the answer? 수치가 아닙니다. Okay. Then I have to define f as a cosine x minus 1. Function x, which is cosine x minus 1, and f 0 should be okay 1. So in which case, in the previous one, now instead of this one, I can plug f. So the answer is endpoint. 그 값이 다른 부호를 가지지 않습니다. So this is the problem. It will work only one-to-one function. Okay. Then I want to find the unit root cosine function between 0 and pi. Okay. Root is 1 point, so it is half pi, right? Half of the pi, which is pi 2. Okay. So okay, in the unit root, it create no problem for your homework because the implied volatility and option price is one-to-one relationship. It is monotonic function, so you can apply this easily. In this case, in the cosine function, okay, cosine function looks like this. Okay, so this is pi. And this is 2 pi. And in the cosine function, what I want you to do is actually between this area, these 2 points, I want to find the point that makes cosine function equal to 1, actually, which is this point. But unit root function, when it finds the solution, basically they compare. So what I did is I transformed this function so that this is the cosine function minus 1. Okay. And for what unit root function did, it compared these 2 points, and since these 2 points have the same sign, okay, it cannot find the solution. In order to find the solution, one should be below 0 and one should be greater than 0. Right? Then it uses routine to find this one. Okay. But anyway, between option price and volatility, so this is volatility and option price. It has this linear relation, it has monotonic relationship, so there will be no problem to do your homework. Okay. Any question?
What data are we using? The price of any options?
No, so the thing is that you have to make a function, so that if I enter some value, it should give implied volatility.
Oh.
So like if I type option price, underlying asset price, risk-free rate, dividend rate, and then time to maturity, exercise price, then it should calculate implied volatility. Okay. So you should write something like this. Okay. But instead of this small s, I have to plug this BSD. Okay, any question? Okay, let's take 15-minute break and resume the class. The previous class about 투자론, investment theory. I tried to do the class next week because a student said that next week is midterm exam period, so there shouldn't be any class. How about you? If you want, I will have a class. Yeah. So do you wanna focus on midterm exam?
Yeah.
Okay. So it means there is no class next week. Okay. But instead, I expect higher quality of your midterm exam. Okay.
Oh, I have a question about the midterm exam.
Yes.
I had a look at it, and the question number 2, there's this timetable of events in Korea, right?
Yes.
Is there an English version too? Because it's
Yes, there is English version.
Really?
Yes.
Isn't it in the second?
Temporary service interruption. Okay.
It's on the Sunday.
What? I don't know, but there is a problem in the Google web page. Yes, that's strange. Will it work? Now, after the earthquake in Japan, the Google service become very unstable. Okay. Ping neighbor. Oh, even neighbor doesn't work. I think there is a network problem. But this worked. Ping. Okay, midterm exam number 2, event data. You can open the Excel file. Okay, so it is Korean and there is English version. Yeah, they contain exactly same information. Any other question about midterm exam? So it is midterm is due 23rd. So you have about 2 weeks from now. Okay. What's this topic? Multiple regression model.
Again, for the midterm or for the term paper, I would like to do just investment in gold, basically.
That's fine. Okay. That's fine.
I'm expecting some more major crises.
Oh, so you want to invest in safe asset?
Exactly.
Okay.
So that would be like the structure of my paper, explaining that.
Okay.
Due to expecting crises, etc., investing in gold would be a good idea.
Yeah, that makes sense. Okay, about the regression, okay. So this is basically all the equation of beta UR estimate, and the OLS estimate for the beta looks like this. Okay. And how do we know that X prime exists? To calculate in order to get this beta, which is OLS estimate, of course, this inverse matrix should exist. And inverse matrix exists when? When does it exist? Okay, but basically, how do we know that this inverse matrix exists?
The determinant exists.
Yes, so when does determinant is positive? Non-zero. When? When determinant is non-zero. Okay, what should be the rank of X then? Do you remember what is the rank? Here, what is the rank of the matrix? J, what is the rank of the matrix?
The number of independent vector in matrix.
Exactly. So when this inverse matrix exists, what should be the rank? What should be the rank? 1? No. So number of so it means that x prime x should have full rank, right? It is square matrix, so it should have full rank. In order to have that one have full rank, the rank for x should be, in this case, x is n plus 1, so basically the rank of the x should be n plus 1. Basically, these data matrix should be independent of each other. Okay? Each column should be independent of each other. If each column is independent of each other, x prime x is invertible because it is full rank, which is n plus 1. So to remind you, again, this is our empirical, it is our specification, y is full dependent variable, x are the data, independent variable, and basically we want to find this relationship. Basically we want to find this beta. And one idea to find the beta is find the beta that minimize some of the square errors. The solution for that is this one. Okay. And about the property, actually, suppose we divide each side by t. T is number of observations, right? How many times we observe the data? Okay. So number of observations. So this is very similar. You can type accepted x prime e t term. So by the law of large numbers, okay, this one goes to 0. Why? St is equal to y. What is the law of the large number? So what is the law of the large number?
Law the large number. I'm not sure, but I guess if the number gets larger and larger, then it approaches to the well, in that case, the t gets larger and larger than the
Did we run low or large numbers in high school?
I learned in the statistic class.
I mean, even in high school. Actually, I cannot remember whether I learned it or not. 현재 what is low or large numbers? Often called the LLM. Okay.
I guess P is larger, we can get the receiver to use it.
Exact what? Yes. If we have a large T, it goes to exact what? Okay. J. You can show a screen. Okay. You are typing low large numbers, right? You are slowly low large numbers, right? What is it?
I know that it's very hard to express in English.
No, it is not difficult to
So,
express in English.
When the number is going up, then what is the 확률 in English?
Probability.
Yeah, probability will be upgrade more and more when the
No.
number is going up.
Okay, here what is that? No, do you remember?
That's very, very long ago.
No. So what is the result from Google search?
Well, I searched it in Korean, but when the size of the samples get larger, then the samples statistics will be same as the statistics in the population.
Exactly. So in this case, if we have a large number, sample mean becomes a mean of the true parameter, right? So in this case, we can regard this one divided by t. You can find the sample mean of the x epsilon, right? X sample mean of x epsilon. So what is the if we have big T, this sample mean of x epsilon, right? So x epsilon is basically looks like this one looks like this one, right? X T, right? So it's vector. X is matrix and epsilon is a vector. So it means, right, we should convert it to the true mean of x epsilon. What's the true mean of x epsilon? It is 0, right? Because x is just constant. We regard x. You can, for this class, you can simply regard x is just data. It is given, right? And the only unknown variable is epsilon, right? The mean of epsilon is 0, right? So if we have large data, we convert to true mean, right? True mean of the epsilon variable, x epsilon, which mean of which should be set to the mean of the epsilon, which is 0. So for large sample, we can ignore this term because it equals 0, right? Equals 0. So we are back to equation 5. Okay? Equation 5 is that one. Okay. Right? So this is we have computed this one. So we go this equation. Okay. What is the significance of pre-multiplying equation 4 by x? Okay. So again, when n is 1, okay, let's write down this one. So if we have only one, okay, actually one constant and one data, okay, one data, then it is univariate regression, right? We already learned. Then x prime y, x prime s beta looks like this part, and x prime, so it looks like this, and y is the dependent variable, and x prime x looks like this, right? And beta 0, beta 1 is something we want to calculate. And if we do the matrix operation, then this term looks like this, right? And if we come to the inverse matrix, okay, over there, and we calculate beta naught and beta 1, right? Beta 1, so beta naught and beta 1 looks like this, and if we calculate the inverse matrix, it looks like this, and then it looks like this, okay? And then we can rewrite this denominator with blah blah blah. Then basically we have looks like this, which is exactly the same one that we calculated in the two weeks ago. So here, basically beta 1 is the ratio of the covariance and variance, covariance between y and x and variance of the x. And beta 0 is simply plot beta 1 and yeah, y bar and x bar is the sample mean of the y and sample mean of the x. So when we have n equals 1, it is easy to write it down. When n equals 2, okay, then we have this more horrible, right, horrible equation. But again, there is a beauty of matrix algebra. If we do the matrix algebra, simply it looks like this. Very helpful. So it is still easy to use. Now let's go to statistical property. Again, for our regression OLS beta looks like this. Okay, beta looks like this, and then we can plug y, as you know, y equals x beta plus epsilon, right? And then we plug this one and we calculate this. Then this cancels out, and we have only beta, and we have this part. And then if we take expectation of each side, then conveniently expected value of our estimate becomes actually true beta, right? Which means that our OLS estimator, okay, our OLS estimator is the same to true beta in the model on average, not on average, actually in expectation. This property is called unbiased estimator. So our OLS beta is unbiased estimator of the true beta. Next, okay, let's calculate cross product of the beta. Okay, so cross product of beta is something similar to the variance, right? So beta, so we know beta is the expected value of beta hat, right? So it is similar to the variance. So anyway, let's calculate beta, estimated beta minus beta, and estimated beta prime. And if we do this operator, for this part, we already know this part is equal to this one, right? This part is equal to this one. And we have transpose. So transpose is this one is we should change the order. So it looks like this, right? And then convenience x is all given. You can evaluate the data, non-stochastic. So expectation goes inside, and we can put this all x outside. And by the assumption, this expectation of epsilon prime is sigma squared and I, right? Because epsilons are all, from our assumption, epsilons are all independent of each other. So up diagonal term of epsilon s prime is all 0, and diagonal term is simply epsilon I squared, which is simply variance of the epsilon, which is sigma squared. So it is sigma squared, and it is identity metric, so we can ignore that. It is a scalar. We can go outside, and then this one cancels out, and we can go with this part. Right? So basically, the variance covariance matrix of the beta looks like this. Note that, okay, variance beta I is slightly different, right? It is so beta is vector, right? It is vector. It is a number of our estimate. So basically, this d beta is including these diagonal terms are is basically beta i's variance, but up diagonal terms are all covariance between betas. Okay, covariance estimating beta. So note that variance of beta I, which is the ith element of this one, which is diagonal term, ith diagonal term of this matrix, which looks like this. Or actually, which is not always same to this one. Note that we are indexing the first row of I by I equal 1, okay? Because the first one is a constant, right? And we have 1 plus n number of independent variables, including constant, and the very first one, which we call zeroth column, zeroth element, which is the basically estimate for the constant term, intercept term. Okay. And as an estimate of sigma square, usually, okay, so in this case, it is sigma square is our assumed, right? It is our assumption. We are assuming that this epsilon have all same variance and they are independent on each other. But problem is that actually we don't know exactly what is the value of this one. And for this one, we use this one for the estimation. Okay. So once we do the regression, and from regression we can get errors for the regression. Well, it is basically y minus y hat. Right? Given y minus our estimate of y. And then square root, basically square sum of the squares of that regression error, and we divide by degree of the freedom, and we will get unbiased estimate of this variance. In addition, if we assume that the errors are normally distributed, if we assume this error term normally distributed, then the ratio between the two is basically, since this is normal distribution, so it is square is chi-square, and then sum of chi-square distribution is again chi-square distribution. So basically the ratio between the two is a chi-square distribution. This one is chi-square distribution, and this is normal distribution, right? So the ratio between the two is t distribution. Okay. So this part is called standard error, right? In your homework, you have standard errors, right? And this part is basically, when we are assuming 0, this part is size of the coefficient, right? So anyway, the ratio between the two is take the t distribution, and in your homework, what you usually get is this part, right? Because this one is usually set to 0 on the null hypothesis. So this is a standard error, and this is your coefficient ratio between them. The t distribution under the hypothesis that your coefficient is 0. And where this term is typified by this one. So let's actually try this one. Okay. Let's go to R. Okay, R. So CAPM. Okay, so this is y, and x is basically to match the notation. Let's say x is column bind of market factor, okay, and SMB and HML. Okay, they are x, and let's delete this one, and y is basically EIBM, right? So the beta, so okay, let's learn this one. Okay, so x looks like this and y looks like this. Okay, and so the beta, okay, beta should solve our estimated beta is like, let's call it just b. B is solve of x prime x, which is t transpose of the x, and then do the matrix operation x prime x inverse x. Okay, so and x prime x inverse x prime, so t Oh. Right. So this should be the beta, right? This is in line with this formula, right? This is our estimate of the beta, right? So let's do it. It will take, it is inefficient, but solve. Okay. Okay, so beta looks like this, okay? Which is exactly same to the Lm. This should be equal to the Lm minus x minus 1 plus x, right? So they have exactly the same value. Okay. So this is B. Actually, the more efficient one. So solve the better one is basically solve I think this is a better routine. This should get the same one. Okay, same. Okay, so this is the beta we get, right? And now we have a beta. So let's calculate our standard errors, right? So standard error is in our equation. Standard error is, okay, basically standard error is this term, right? This whole thing. Okay, standard error is this one. So then we have to calculate this part, right? So in order to calculate this part, we have to first calculate our estimate of this variance, right? So in order to calculate variance, basically, okay. So this is our coefficient. So our estimated y hat should be, what should be the y hat? Okay, y hat is, since we know x, so x multiplied by b should be y hat, right? Right? So our model looks like y x beta plus epsilon, right? So y is our data. And once we estimate a beta, then to estimate y, right? This is y hat, right? Once we estimate this beta and we plot the data, then we should get the estimate of the y, right? So y is our forecast. So suppose this is the data, and this is x, and if we have this relationship, then this should be our y hat, and the distance between this and regression error, right? This is epsilon hat. So y hat looks like this. Therefore, okay, let's calculate y hat. Right, y hat looks like this. So it is our estimate, and then of course, then we can calculate distance between y and y hat, right? So y minus y hat is basically e, right? It is our regression error, right? Y is our dependent variable, and y hat is our estimate of the dependent variable. So it is regression error. So e is basically this part. Okay, this part, this hat part. Okay, so therefore we have the e. So what we have to do is calculate is basically we have to calculate this part. So basically s square is, what is the t? Okay, t minus, okay, t minus n minus 1, right? n minus 1, and we know n is 3, okay? And 3, which is the number of the factor, probability 3 factor. So multiplied by, okay, e, okay, what is the E. So E, okay, let me click E. Okay. Sum E. Okay, good. Okay. And sum. Okay. So this is the S2. Okay. S square. Or 3. S2 looks like this, so S2 is right. Oh, this is huge. Ah, damn. Okay. Okay, actually, I have to divide with this one. I have to divide. Okay. Okay, so I have to divide. Right, so this is S square. So S square looks like S square. So this is our sample standard deviation, right? Sample standard deviation. So we have this part. So basically, beta to check the notation. Okay, so this is dB. This dB thing is okay. This dB d beta. Okay, d beta looks like S square multiplied by. Now instead of this one, I use our estimate of the sigma square, right? So this is the solved inverse matrix of x prime x and x, right? So this is our d beta. So d beta, this thing, okay? Okay, d beta. Now our standard error is basically diagonal element of this one, right? So therefore, our standard error, let me get rid of this one. So basically, our standard error SE is basically diagonal term of d beta. Okay, so SE looks like this. Here our standard error. So T value is ratio between our beta hat and this one. Right? So T value would be our B hat, right? Beta B, actually P divided by SE. This should be our standard error. Okay, which should be our T value. Okay. Okay, T value, so T looks like this. So let's collect together, okay? Let's collect C bind of B and standard error and T. If we put them together, it looks like this. And we can compare this value with our regression result. So Lm y minus 1 plus x, okay? And summary. We can compare this, okay, this value and our previous one, okay. So let's compare this. So our coefficient, this 1, 2, 3 is exactly the same to this one, and our standard error, they are different. I don't know why. I don't know. Oh, okay. Yeah, sorry, yeah. So I have to do the square root of this one. Okay. Square root of the d beta, yeah. Yes, I have to square root of the this one, then it should be same. So, process source, and summary of this one, and then okay, so let's compare. No, this is not updated. Square root, let's see. So beta hat, beta hat. Okay, B is the same. P is the same to this one. So, oops, y hat looks like this. Epsilon is y minus y hat, and 3. So, 적절한 배열이 아닙니다. Solve. S2. S2. And then strange why I cannot multiply. Okay. Why I cannot? Okay. How about this? Okay. That's strange why I cannot. Okay, I'll read this one as a matrix. So, yeah. Okay, so I cannot calculate this one directly because R regard S2 as a matrix, 1 by 1 matrix, and it is 3 by 3 matrix. So I cannot multiply 1 by 1 matrix and 3 by 3 matrix unless I regard this 1 by 1 matrix as a constant. And so to do that, I simply plug the first element of this one. Okay, and this is D beta. Okay, now it works. And then standard error should be diagonal term of the standard error, this one. Okay. So standard error looks like okay. And I can compare this one with okay. Let's FF with okay, and then SE. Okay, now we have almost same, but because of the inversion of the matrix, I can get a slight error. So yes, so the regression standard error is exactly, not exactly, but almost similar to the standard error that I calculate. Standard error I calculate It is through this linear algebra, right? These standard errors. The diagonal term of this s square x prime x inverse, right? And therefore t value is simply t value, this is t value under the null hypothesis that coefficients are 0. So t value is basically b divided by se, right? So t looks like this, and this t value should be similar to this one, and they are indeed similar to each other. Okay? And now next, I want to recover this p value, which is actually slightly more. I need more command. So, but anyway, let's try. First, let's call this one as a degree of freedom. Degree of freedom. Degree of the freedom, and degree of freedom is simply t minus number of parameters, which is n, okay, which is the degree of the freedom. And then to calculate the p value of the t distribution, okay, cumulative, okay, r t distribution, okay, r t dis what? Somehow I cannot type D in the strange. Why I cannot type D? This keyboard called D doesn't work. Okay, R. Okay, R, and then okay, R project, and this is annoying. D. Interesting. Why I cannot type? Okay, so D. Oh, now I can type. So R T distribution. Control X into the Google search. R student T distribution, and then PT. Okay, PT is true, false. PT is the, I think, vector of probabilities. Okay, I think it is the cumulative distribution. Okay, so PT. Okay. So we have a t value, so what we wanted, the pt and t, and degree of freedom is t minus n, right? So, okay, so this is p value, which is approximately similar to this one. Okay, so p value is basically p value is basically pt and plug t value, and then we can plug degree of the freedom, right? So it looks like this. So let's run the program. Source, right? So let me now compare the results. So FF rate looks like this. Oh, summary. Right. Yeah. Looks like this, and to recover the value I calculated, so the value is C bind, and first I plug the P, which is our coefficient, and second one is our standard error, third one is T, next one is P val, right? So didn't I save? Okay, huh? Yeah. What's wrong? Okay, let me try again. Okay. Somehow we cannot save the file. Okay, so to compare our value B and then SE and T value and P value. Okay, so these four values are approximately similar to this one actually. This is P value, so actually I have to minus 1 minus this one. Okay, 1 minus this one, which is okay, actually 1 minus this one and multiplied by 2. Okay, now P value looks like this and our regression model looks like this. Okay, so the P value I calculated is almost similar to the regression result, right? So again, to explain this part, so this part is basically value of this area. The value of this area, right? So this is a cumulative distribution. So this part PT TDF is the probability of T, which is probability that T is less than equal to this particular point, given the degree of freedom df, right? And in the hypothesis testing, basically we wanna know the size of this part plus size of this part, because this p value is the absolute value of the t is greater than, it is probability that the realization of t is greater than this absolute value of the this one. Right, so therefore, I have to subtract 1 minus this, then I have this part, and I have another this part, so I have to multiply 2. Right, so therefore, I have a p-value. So this is p-value. So therefore, basically, I recovered almost all these coefficients through the matrix algebra. Okay, and what else do we have? So this is residual squared error, which is okay, 8.216. Residual squared error is, in this case, is simply square root of the S2. S2 is 8.24, which is almost similar to 8.21, right? And DF is 130. Oh, it is, why degree of freedom is different? Okay. I have to subtract -1 because I dropped the first data, right? Because the return data, so I dropped the very first data. So, okay, then everything should be matched. And R square, you already learned how to calculate R square. So R square is basically, okay, I'll not go over this part, but anyway, you can calculate R square, and yeah, I think we recover almost everything. Okay. Any question? So in your homework, which should be due in the next 2 weeks, I think you already computed, actually you have to do multi-factor, three-factor regression again, right? Because you didn't use return data and you used the closing price. So please do that regression again. And then in addition to that, please recover, okay, recover beta and standard error, t value and p value and everything through this linear algebra, okay? As I just did. So basically, what I want you to do is basically recover, except this residual part, it is simply quantized. So except this part, you should recover every output of this summary result of regression through linear algebra. Okay? Any question? Okay, so let me write down the homework. So homework which should be due to, actually this is today's homework, so let me write down today's date. First homework was implied volatility, and second one was okay. So I showed you almost everything. So for this part, F statistic and this p value and r squared or just the r squared, you have to Google the concept of those and you have to construct them yourself. Okay, I think this is the end of today's class. Any question about today's part?
So this homework is due to April 29th.
Yes. Yes. So your midterm is 1 week away, and yeah, you can do the homework after the midterm. Okay. Thank you, and see you in 2 weeks.